Hello everyone, I'm Adam. In this problem, we're going to find all solutions to our equation given here as sine of x over 2 plus cosine of x equal to 0. And we're going to find those solutions on the interval from 0 to 2 pi, including 0, but not including 2 pi. So what we have here to start with is a trigonometric equation. And just like you would in algebra, how we want to start by solving this is, if we can, factor out something common or combine like terms if we can. But since we have a sine and a cosine, right off the bat there's not really much that we can do. However, if we look at this, we have sine of x over 2, and we know we have an identity that deals with that we can kind of substitute and maybe rewrite this in terms of something dealing with cosine. Maybe after we do that, we can continue a little bit more. So let's take a look at that before we go any further. So the identity, let's see, right, that we have sine of, say, x over 2 is plus or minus the square root of, say, 1 minus cosine of x, all divided by 2. Okay? So we can make that substitution. But before we do that, there's a little nuance that we have to pay attention to. The fact that we're finding solutions from 0 to 2 pi. Right? So our x is greater than or equal to 0 and less than 2 pi. Right? So that's the angle on our interval here, but inside of our sine here is x over 2. So if we look at this interval and kind of divide through by 2 if we want, this would imply, right, that, say, x over 2 is greater than or equal to 0, but less than pi. And why is that important? Well, when we look at the identity, there's a plus or a minus, right? But if x over 2, the angle inside of sine, is between 0 and pi, that means sine is positive. So when we make this substitution, we're only going to have plus the square root. And so let's do that. So substituting in for sine of x over 2, right, is going to be positive, or plus the square root, 1 minus cosine x over 2, plus cosine x, and is equal to 0. Okay, now what can we do here? Well, we can get rid of the square root by squaring, right? So we can square both sides of an equation. Whatever you do to one, you do to the other, as always. But if we square out what we have on the left-hand side, yes, in some part we'll get rid of the square root, but in a FOILing process, we'll end up with a square root in the end also. So an easier thing that we can do is try to isolate the square root on one side. We'll bring our cosine to the other, and then we'll try squaring. So we have our square root of 1 minus cosine x over 2, and we'll subtract cosine x to the other side. So this will be equal to negative cosine x. Now, when we square both sides, we'll get rid of the square root on the left and just have, say, positive cosine squared on the right. So squaring our square root, right, that's going to leave us with 1 minus, say, cosine x over 2, and that's equal to, again, positive, say, cosine squared x. Okay? So what can we do now? Well, we have a cosine squared, and I see on the left-hand side, say, a cosine to the first power. So if we could bring everything over to the left-hand side, it looks like we're going to have something like a quadratic equation in terms of cosine. And from algebra, we know how to factor quadratics, so we'll see if we can do that. So we'll bring everything over to the left. So I'll subtract our cosine squared. We have, say, minus cosine squared x. And we can simplify this just by dividing through by 2. So we would have, say, minus 1/2 cosine of x plus a positive 1/2. And that would all be equal to 0. Okay. Now, I want to try and factor this. And if you're like me, when you're trying to factor quadratics, I personally like to, if I can, get rid of any fractions and also turn the leading coefficient positive if I can. So we see that we have a negative 1/2, a positive 1/2, and just a negative out in front. So I think if we multiply through by, say, a negative 2, right on both sides, that kind of get us what we want. So multiplying through with a negative 2, we'll have, say, positive 2 cosine squared x and plus say cosine x, and minus 1, and is equal to 0. Okay, so let's see if we can factor that. So we have 2 cosine squared. So the factors of that are going to be 2 cosine, right, and cosine. And I think if we have, say, a minus 1 and a plus 1, that'll get us what we want. If we FOIL back out, we get back to 2 cosine squared plus cosine minus 1 and equal to 0. Okay, now we're ready to start solving for this. So we factored this equation equal to 0, and why do we want to do that to start with? Well, whenever you have something factored set equal to 0, we can set each factor equal to 0 and continue to solve from there. So that's what we're going to do. So we'll take our first factor, say 2 cosine x minus 1, right, set that equal to 0 and solve for it. So if we add 1 and then divide by 2, we get where cosine of x is equal to positive 1/2, right? And so where is cosine of x equal to positive 1/2, or what angle gives us a cosine value of positive 1/2? Well, we know it's x equal to, say, pi over 3 and 5 pi over 3. Okay, now we're going to take a look at the next part. So let's look at our factor cosine x, right, plus 1 equal to 0. Well, solve for this, subtract 1 from both sides. So we get cosine x is equal to negative 1. And what angle gives us a cosine value of negative 1? And again, so x equal to pi is what gives us cosine of negative 1. And going back here, why we got pi over 3 and 5 pi over 3 is, once again, we're only taking x values on our interval from 0 to 2 pi. So that's what we would get. Now, does this mean we're done? Right? Do we have these solutions? Well, going back to this thing we were talking about in the beginning, where we only took the positive part of this square root, have to pay attention here. When we went through and solved, once we made our substitution, we put in the positive square root, and then we squared it. But keep in mind what the resulting thing we got was 1 minus cosine x over 2. We would have gotten this if we plugged in the positive or the negative, because whenever you square something, it just comes out to be positive. So what that means is some of these solutions might have been solutions to something if we plugged in if it was the negative, right, versus just the positive. So some of these solutions might be extraneous. So what we're going to have to do is do what we were taught in basic algebra when you're solving for an equation, is check the solutions to see which are the ones we want. So we'll start by checking our x equals pi over 3. Let's see here. So check x equals pi over 3. So we're just going to plug this back into our original, right, equation. So x at pi over 3, right, plugging in for x, so x over 2 would actually be, right, pi over 6 plus cosine pi over 3. Right? And we want to see if that gives us 0. Well, sine of pi over 6 is 1/2, plus cosine of pi over 3 is 1/2, right? And that's equal to 1, which is not equal to 0, which is what we want. So we can see x equal to pi over 3 is an extraneous solution. Well, let's check x equal to 5 pi over 3. Okay. So same thing. We'll take sine of 5 pi over 3 over 2, so giving us sine of 5 pi over 6 plus cosine of 5 pi over 3. And so sine of 5 pi over 6, right, gives us a positive half, plus cosine of 5 pi over 3 gives us a positive 1/2. And again, that's equal to 1, which is not equal to 0. Okay. So pi over 3 and 5 pi over 3 so far are extraneous. Well, let's check our very last one, x equal to pi. So if we plug that in, so again, we'll have sine of, say, x equal to pi, so pi over 2, and plus cosine of pi. Right, so sine of pi over 2 is 1, plus cosine of pi is negative 1. So 1 plus negative 1 gives us 0. So there's our kind of solution that we want. So x equal to pi is going to be our solution for our equation on the interval from 0 to 2 pi. Okay. So now what we want to do is graph our equation and try to confirm the result that we just got. So with our graphing utility, let's go in to our equation editor, and for y equals, so what we're going to type in is the left-hand side of our equation, so sine of x over 2 plus cosine of x. And let's go into our window. So we're essentially trying to look for solutions on the interval from 0 to 2 pi, so we'll take our x min from 0 to x max 2 times pi. And for the x scale, let's go ahead and take it as, say, pi over 3. So on our x-axis, we'll count in increments of pi over 3. And y min will go from negative 3 to 3. And the y scale we can leave as 1. So if we press graph, just to get a look at this, right, so what we're hoping to see is this equation, right, which we solved equal to 0, is that at the x value pi is where the graph will cross or touch the x-axis. And so if we look at our pi over 3 tick marks, if we count over 3 tick marks, that's kind of where it looks like the graph is touching, but we'll confirm that. So let's go into our calc menu, so second trace, and we'll select 0. It's trying to find the 0 of the function. So for our left bound, just arrow somewhere close to what looks like where the graph is touching the x-axis. And right bound, move it over to the right-hand side of where it's touching, or looks like it's touching. And for our guess point, just move somewhere in between, or as close as we can to where it looks like it's touching, and press enter. So we get a 0 of x, or where y is 0, we get an x value of 3.1415931, which is going to be x equal to pi. So there we have it confirmed. Thank you very much.